Hello guys, on this video we will help Team Cs. If you remember, last year we was on Team Trees, trying to help plant a lot of trees, and this year we had exactly the same, trying to clean the mess that we have on our oceans with all the garbage that we have. So you will see a donation box on the next to this video. You can help donate for, they aim to collect 30 tons of pounds of garbage from the oceans. You can see the different videos. This started with Mr. Beast together with Mark Roberts, and they have pretty cool videos explaining how they are trying to do it. Together with organizations like the Ocean Cleanup, they will have these types of boats. They use as well nets to try to clean all the garbage that comes from rivers and collect all this garbage and filter it basically. So yeah, I think it's a pretty cool cause to try to help them. Please feel free to give a donation. And I will try to explain how to do this in 3D, and I think it's a pretty cool project. First, you need a different plugins that they are totally free. You will need Tyflow, it's free, download it from the webpage. You will need Hot for Max, it's as well free, you have it from Max 2016 to 2022. You will need i2 from IT Software, you have the clone modifier, that I use it a lot. They are super useful things. And as well, I download this street garbage you can see on a Sketchfab, it's totally free from the user Thunder. Thanks to share these type of things. We will try to do this. So we will create a lot of garbage, and the garbage will float on the ocean in a nice way. I think it's pretty cool because it tries to get submerged and it goes back to surface, and all this will be pretty fast. I mean, check how many objects I am having on viewport, and all this will be collected, as you can see, by these collectors that are on each boat. The boat is called Interceptor and it's collecting garbage, and we will do it with physx. All this goes into containers and they take out these containers. So yeah, I think it's pretty cool to have all this. I love Tyflow, how fast it is. And yeah, so I will start with an empty scene. In Patreon you will have the initial files and the end files. If not, you can do this yourself. I have here a plane subdivided with the Houdini for Ocean. You can check these parameters here, 8, 15, 30, and you can tweak all this. You can tweak the scale, as you can see, it's pretty cool. Do it yourself if you don't have this scene, but that's one of the things that we will have. And here is the convoy belt. The convoy belt, what it is, it starts with this box with edit poly. I create 4 boxes with this box. I use a clone modifier that I love it. I multiply this multiple times, and then a path deform. And the path deform, I select a spline that I have here, and then I animate this. I animate this percentage, and what this is doing is that it's animating this. Going quite fast, but because I want to clean all this garbage as fast as possible. So that's what you have on the scene. So for starters, what I want to do is create a net, because as you saw, these interceptors has a net. Here I create a box with the clone modifier and the path deform that right now is not pointing to anywhere because we need to create something. So we will go to helpers, and on helpers I will create a spline that we will project. Create a spline there. Doesn't need to be perfect, something like that. This will be our net to collect things. Move it a little higher, something like that. We need to project this to the surface of the ocean. To do that, we will use a icon form, and we will select this ocean. And as you can see, it's trying to go there, but it will do some weird stuff. Like, yeah, it's moving quite a lot. That's because first, we don't have so many points on this curve. If you go to the line, we only have this number of points. So we will add a spline optimize. With X, it works better. Normalize a spline is what we want. With normalize, you can do show nodes, and we will add more nodes. Something like that. We don't need too many neither. And now with the icon form, I found that sometimes with the normalized spline, when you do the show nodes, it has some problems to display accordingly, but I think that will work at the end. So right now you can see that these nodes are displayed there. What we can do now when we go there is that we can go to the path deform, and we can pick this spline. You can pick this spline and it will work. It doesn't display correctly, but I think this is a bug with the icon form. together with the show nodes, but you can ignore it for now because, yeah, you see, it's going there, but it's not visualizing it correctly. But the thing is working. Then another thing that I would like to do most of the times is that on this path deform, I select the preserve form, because if not, it's deforming and I don't want this to deform. I like to use preserve form and by element. So instead of deforming, it will follow the curve. As you can see, it's doing some crazy things because it's trying to raycast based on closest surface, and we don't want that. Instead of using conform faces, I will use raycast. This will throw a ray on Z, and now it's doing something much nicer. It's following accordingly. It's what we want. We will need to delete these ones here, so for that we can add an edit poly that I had, but this edit poly doesn't work for what I want now. Let's add another edit poly, and let's delete this, and this. So now we have a net. The cool thing of this net is that it goes like 2 meters deep, so the fish can pass through, and it's only collecting what is on the surface, that is this garbage. So yeah, that's working. We have a net, and it's following our surface. Now let's go with Tyflow. I will use Tyflow to distribute this garbage that is floating there. So I will go there and Tyflow, create a Tyflow, open editor, and here, if I select the ocean on viewport, right click, preset flows, and we have already a simple scatter. This will say, do you want to scatter on the selected object? Because we have it selected before. I say yes, and it will scatter automatically on this object. Something that I would like to do here is to add force. So let's add this here, and I will add a force. On a strength, on gravity, you can press this V and you have real world values, so we will have the gravity with real world values. Depending of your scene scale, you will have different values. I like to go to unit setup and system units. 1 unit is 10 centimeters, because for big scales, scenes, it works fine, so you will need a 0.1 on gravity. Now, all this will fall down. What I like to use here now is the surface force. So I will select surface force. With this, I will select this Houdini Ocean, and this will try to move the particles based on this surface. Now, you will see that this is quite slow. That can be a problem because I want to do things fast, and because this is very dense. So before I do that, let's delete the Ocean on viewport from here, and I will copy this Ocean viewport. Let's do a clone. Let's do a copy. I will call this Ocean Tyflow. So for Tyflow, I will use, and let's delete the Houdini Ocean actually. I will use exactly the same plane, but with way less segments. I don't know if 40-40 will be enough. Maybe 40-40 will not be enough, but something like that. We don't need so many things. And now on the Houdini Ocean, you can do right click, copy, and on Tyflow, we will instance. Right click here on the modifier, paste instance, so now when we change one, we change the other, but you can see that it's way lower res. And that's quite useful because right now on surface force, I will use this one. It will take way less time. And actually I can use as well the same on distribution, will take less time when it starts, and on rotation too, because it's using this mesh to align the objects. This will accelerate a lot of things. Now, as you can see, because the surface force is happening every frame, now I can move this way faster. And for what I will be doing, actually I can turn off on the viewport to have only the low res. To accelerate calculations as well, make sure that this spline is selecting the Ocean Tyflow because it's a low res version, and all this will go way faster. As you can see now, it's way faster than before. Now, when we create this Tyflow, we can see some weird things going on, but it's part of what we want. So if we go back to Ocean Force, let's try to make this work in a nicer way. I want attraction, but I don't want anything else. Follow normals, all this is fine. I only want this attraction. And the force, I only want this happening when these particles are below the surface of the water, so let's turn on above. So if they are higher, it will not do anything. If they go below, because now we have gravity, they will try to go up. Now our gravity is 0.1. I want that the surface force is only a little higher than the gravity, so it contrarrests the gravity. Something like 0.15, I think that can work. Now you can see it's way more natural. Some particles are moving along with the surface of the ocean. That's quite cool, but it's maybe a little too much. As you can see, they go way faster. So we will add a drag, and with this, it's called slow. It's a drag in Tyflow, and this drag can be maybe close to 10. We can see if it's still working, and I think I like it. Maybe we can do that this drag, as you can see with these objects there, maybe it's too fast here. I can try to make that the drag is higher on X and Y more than Z, so maybe go to 17 and 17 there. Yeah, something like that. And as well, I will limit the velocity. So one thing to check the velocities of these objects is to go into display data. Display data, when we say I don't want the bird ID, but I want the velocity magnitude. So this is going to 0.4 more or less. I don't want that these particles, they go too fast. So I can add a limiter there. And on the limiter, I will say limit velocity. And I will limit maybe the velocity on X. On X, it's 0.4, so if I limit to 0.2, they will not go faster than 0.2, and minus 0.2. And you can see that now they are go way slower. But on the other directions, maybe on I we can do the same, 0.2 and minus 0.2. So we limit a little the velocity based on the force that they have. And then when we are, now it's time to add the garbage. So I download this and I will drag and drop there, import file. This will be imported here. Let's put it there and place it, instead of helpers, I will place this on garbage geo. It's nice to have these things tidy and organized. One thing that I would like to do, first we need material. And something that I like a lot is, let's create a new view. I will use the utilities, the import PBR material. What we need to do is import files and select whatever it is this. Here I will import these materials from our object, create one material, and I have it already created before, so it's selecting it, but it will create automatically this material for you. That it's quite cool. Replace it because it was already created, sorry, and let's do it this way, assign to selection, so we have the materials. Now, in order for this to be imported correctly into Tyflow, what I used to do is to create first a group, and this will be garbage. And now we create this garbage group there, and inside Tyflow, I will go into the shape, and instead of shape, I will select here reference node, and I will select this garbage group that we created. It's too big, don't worry, scale 100%, and it's creating the garbage, but it's instancing everything. What we need to do is go into split group members, center pivots, and yeah, I will do instance material and inherit from reference. In order to display the material here, if you want it, the easiest for me is to go to the mesh, turn off render only. Now this is meshing, and you can assign this directly to Tyflow. You can do assign material to selection, and it's selected. Make sure to turn this render only again on, because if not, it will take some time to, it will create a mesh on viewport and it will take some time. So now we have this, and I think that it's pretty cool. You can see it's once it's simulated, it's really fast, and we have some cool behavior, because some objects will go below the water. This will be even more visible if we increase the scale of that. It will be even more visible if we make this way faster. You can see that because wave goes down quite a bit, objects will go down, and yeah, it can be pretty cool. You have these objects going down, going inside the water, and then taking some time to get up again. So it can create a very cool stuff. I don't want this to be so fast, the wave, but can be quite realistic if you want. Let me do it again, not so big. Now, another thing that I would like to do is to variate the rotation of these elements, because I don't know if it's very visible, but all the objects, if we start increasing, they will point exactly the same way. You can see these two objects are rotated exactly the same. I will go into rotation. It's already based on this mesh. It's increased divergence to 180. So now everything will be rotated in different ways, but I want to restrict the diversion. So I want that it's only rotating 100 degrees on on Z axis, so the axis that points up. So now we shall see these textures. You can see that the points in different ways, and I will add a little of offset on rotation on the other axis as well, but I want only a little of, so 0.15, so they can be not totally following the surface. That's cool, because if not, these papers will look a little weird. So it's good that they follow more or less the orientation of the surface. Because right now this is only a line on the first frame, and let me decrease a little this one. This is only a line on the first frame, and then it keeps this alignment, so it's not realistic when this surface is deforming over time. What I will do is on timing, instead of on event entry that is only evaluated once, I want this to be evaluated every frame. So it will try to keep the alignment all the time. And you can see that can do some weird thing, but also I like these things because it's rotating in a quite natural way. Maybe a little too fast, as you can see here. It's trying to align all the time. So another thing that you can do is to play with interpolation. Interpolation of 1 is that it means that it will try always to snap to this new alignment. But if we do 0.1, it will try to be slower. So it will go to this position, but in a slower way. So it's creating some natural things there, and you can go even lower than that. I think I like it quite a lot. It creates a very natural look. Now, first I would like to delete everything that is here, because this is supposed to be clean. So in the top node, let's be on helpers. Let's create a shape that covers all this area really fast. So something can be a little rough, but more or less something like that. Yes. Let's extrude this big time. And to delete all this area, I will need a delete, drag and drop, and I will use this based on surface test. So based on the surface, I will delete them. I will need to select this thing, and everything that I will not use distance, that is the default. I will use volume inside. Now, if I turn off this that I want to see, elements are only appearing here. And yeah, going there, I would like to add much more objects here. Let's add 2000. You can see that it's fast simulating. Yeah, quite cool, no? Now, something that we will need for the final is that there is no collisions here. So we will see objects like that they are one over the other, and it's not something that we would like. And it's a particle physics, so let's add a particle physics there, and you will not see much. I like a lot to visualize this without collisions. That's the physics, so these things will collide. But because some objects are smaller, some other objects are bigger, I will do this based on, not on absolute radius, but maybe shape radius y. Let's try it. That can work. Maybe x or y. I would like, yeah, x works pretty good. So this is based on a radius. It will not have true collisions, but because at the end we will have a lot of particles, this works very well. You can use as well physx, but I want this to be fast. So, and because the area, we will see that, I think that this is good enough. And now objects are not colliding anymore. They are getting separated one to the other and colliding in a very natural and physical way. I like quite a lot how this is working. And the other thing that I would like to do is to force this a little to go there, because we had a little of motion from the wave, but not so much. So to help that, I will create splines. Let's create another layer that will be FX spline force. And yeah, it's just adding some splines to try to help all this effect. So this will act as a forces. So I would like this going there. I would like these objects going there, but then I would like to create some streams of flow that will try to move this inside. Yeah, this should be enough. You can add more if you want, but this, I think this will work. And what we will do is it's a path force, I think it's called, spline path follow. So path follow, not here, but here. I will add this spline, so I will select this spline force, add selected. Now, by default, we'll do something very weird, I guess. And we need to select follow. We need follow and attraction. Attraction will attract to the curve, but we don't want a spin at all. We only want to attract this. Something I like to do is the custom min max. This normally it helps. It's how long you want to affect this, but well, I will keep it at 200. And then velocity, you can see that by default it's too strong. So objects are going there, but it's way too strong. And I like to do some fall off. This fall off is based on a distance, maybe 30. I don't want to affect all and to create all these streams perfectly, so maybe 20. You can see that, maybe 15, 10. So it will create more force when it's closer, and it will attenuate when it's far away from the curve. And yeah, I don't know, something like that can be cool. And then the other thing is like decrease a lot velocity, because this is way too strong. So we will need 0.04 maybe. And attraction as well, very small attraction. I want that it's there. So now at 0.1 it's too strong, 0.06, I think that this will be the value. We can tweak this later, but now we can see some, let's calculate 200 frames, and you will see that, yeah, that works. So now let's start adding the physics here, and this can be quite cool. We will need to first convert all these objects that are close by, only the close by, to physics. This way, this will be way faster when we have a lot of particles here. So for that, we will need a helper. Let's create a helper there with a point helper here. And let's check the distance. Normally I copy this and I check here below. And you can see that a distance like on this area, it's around 18. So around 18 is where I want to activate these elements. So on Tyflow, I will create a new property test or object test I need for that based on this object that we created, this helper, add selected. And based on a distance when it's like lower than 20, I will switch there. Because we have materials now assigned, we cannot see if this is working or not. On display, you can say display material off. So now you can see that when they are getting closer, they go into this element. And because we don't have forces, it's doing some weird things. So here, I would like to have as well the force gravity. I would like the surface force and the slow and the path follow, because I want this to keep pushing. So let's shift and drag and copy all this there so it still works. But I would like as well a particle physics shape. Physics shape. And this will convert these objects in physics. Now, one problem is that when we add physics, because we have here already gravity, you want to go to the Tyflow. Tyflow is as well on physics and adding gravity, and you don't want the collider neither. So now we have physics, but we don't have any type of collision there. We need to add this element as colliders, and this can be a little tricky because this element is deforming with a path deform, and you don't want an element deforming, you want individual objects moving. So how we do that? Let's turn off this and let's create a new element here that we will import. We will import this object as selected, and let's display Tyflow. So we import this object here that it's assigning a wrong material, but whatever. On display geometry we can say ignore not display material, but this is not moving and this can be a problem. What we will do is separate these elements by individual particles. If you go to geometry and you display ticks, it's only one particle, but in Tyflow we have something that is called element fracture, and when we do that you can see that we create a particle per element. So now we can go back to display geometry, but now how we animate it. To animate that, we can use a object bin. This will use an object on the scene to try to get closer. We will use lock to surface, and what we will do is select the original object that was this box 005, and basically it's trying to point to the original mesh, and yeah, as you can see, it works. It can have some problems time to time, but I will ignore that. I think it will work just fine. Now, we don't have physics in that, so we will add physics shape, but we don't want that this interacts in a physical way. We want this to be a kinematic object. We will use a physics switch. When we switch this to kinematic, this will be a collider, but it will not fall down or will not interact with the other objects. And in theory, this should work. So now, if we enable this, we should see this picking up. Fingers crossed, and yeah, it's working. Nice. So yeah, we are picking objects in a correct way, and it's pretty cool. If you want to add some colliders, because we need to add some colliders, we want the birth objects, and let's display everything. I want to add this as a collider, and I would like to add this as a collider and this as a collider. Add selected. We will do the same. We will clone this physics shape, but now the problem is that this is a convex hull, and a convex hull it will not work because it will try to create. It will not see this concavity here. You want to use mesh. Only use that when this is a collider. So let's add this physics collider. This is turning off automatically these elements. So let's move this around. All the forces are working. Everything is going to the conveyor belt. And in theory, well, now I can see that these forces I can see that the forces from the curve are a little too strong, but you can see how, yeah, this is working pretty fine. Everything is getting applied there. I will say, yeah, this is too strong. So the last tweaks here will be go to the path follow. Let's reduce a little the follow to maybe 0.03 and the traction to 0.03. On display geometry, let's turn again the materials. Now we can not display these spline forces, and we can increase a lot. Turn off the helpers. We can increase a lot the particles, and with this, yeah, we have it. I reduced a little the size. I think it was a little too big, but you can increase the object size and let this play for a while, and you will be seeing like our interceptor from the ocean cleanup. It's collecting the garbage in a very natural and realistic way. As you can see here, all things are being collected, and yeah, everything is falling down into place, all types of garbage. And I hope that you like this tutorial, you learn a little of Tyflow. Remember that if you are one of my followers in Patreon, you will be able to download this scene, and I am posting their exclusive content for my Patreons, showcasing how to use Tyflow and 3ds Max in general, basically. But remember that here the most important is that you collaborate with Team Sys, so give a donation if you would like to try to help the planet. I think it's really important. And yeah, thanks a lot to all my Patreons that supports me. Thank to you to be here checking this video, and if you did a donation, thanks a lot. And thank you guys. See you soon. Bye.